Let's continue with the problem solving for trigonometric ratios. In the previous video, we tried to do two problems, and one thing that I missed mentioning in the previous problem is that we have taken the values as 12 for this cot theta 12 by 5 as 12 and 5 and 13, but in reality this could be it could be it need not be, the ratio need not be this, as you know that you could have all similar triangles have the same ratios. It could be this, it could be that this is 5, this is 12, and this is 13, but it is also possible that this is, let's say, 5 into 3, and this is the whole thing is 12 into 3, or this whole thing is 13 into 3, right? So in general, if you want to write it in general, it's a good idea that you can solve the second problem by considering that this is 5x and this is, let's say, 12x, and this is and this will automatically be 13x if you use a Pythagorean theorem, right? And if you continue to do it, you will realize that your answer will not change. The reason being that you're dealing with ratios, and then the ratios will have to be the same. All right. So with that snippet, let's start with the third problem in the list of problems that we intend to do in this chapter together. So here is the third problem. So given that tan theta plus cot theta is 2, so here's a problem where drawing may not be possible. Not all problems you can draw. So cot theta is equal to 2, and the question is find tan squared theta plus cot squared theta. So the key is to look in patterns, right? So we know that tan theta, cot theta is 1 by tan theta. So let's write that down like that. And 1 by tan theta equal to 2. And the questioner is asking find tan squared theta plus 1 by tan squared theta. So find the value of this. So whenever you see a question like this, it's important to see patterns. So let me remind you that in algebra you had a question like this. Let x plus 1 by x is 2. Find x squared plus 1 by x squared. And the way you used to do it is you used to square this. So you used to say, hey, this is x plus 1 by x the whole squared, because this would be a squared plus b squared plus 2 into ab, which is x into 1 by x, and the whole idea is these x gets cancelled, right? So what you can do is you can substitute this 2 here, so you can say 2 squared is x squared plus 1 by x squared plus 2, or in other words you get x squared plus 1 by x squared equal to 4 minus 2, that is 2. So that's your answer. So in fact here your answer will not be any different, but let's try to, since we know this idea, let's try to do the same with tan theta, right? So what do we need to do to reach from here to here? We need to square it. So let's square it, and let's do the same. 1 by tan theta the whole squared is equal to tan squared theta plus 1 by tan squared theta plus 2 into 2ab, so 2 tan theta into 1 by tan theta. All right. So from here I would urge you to follow the path that we followed just now. Pause the video and try it yourself. So you would have substituted 2 for tan theta plus 1 by tan theta, and here tan theta into 1 by tan theta would have got cancelled exactly the same way as here, and you would have got the answer as 2. Now your answer would not be very different if I were to ask you, let secant theta plus cos theta is equal to, let's say 1, and if I ask you, say, find secant squared theta plus cos squared theta. So your approach would not be very different. Your approach would be exactly the same as you have followed in the previous two patterns, right? Because secant theta is 1 by cos theta, right? So whenever you get a pattern like this, it's important that you remember that pattern and try to proceed within that pattern. All right, so here is the next question. Given that 5 tan theta is 4 and you have to find the value of 8 sin theta minus 3 cos theta and so on. So this can be done in two different ways. So let's first try the simple way by drawing the triangle and finding the value of sine and cos. So here we have tan theta is 4 by 5. So let's not put it as 4 by 5. Rather, let's put it as 4x by 5x, because we know that it could be 4 by 5, it could be 8 by 10, it could be 12 by 15, and so on, right? So let's do that. A, B, and C. So this is your theta, till painted black, perpendicular by base. So this is 4x and this is 5x. So this has to be square root of 5x the whole square plus 4x the whole square. That's equal to square root of 41x. All right, because this is 25 plus 16, that's 41, and the x squared comes out, so square root of 41x. So now the questioner is asking, what is 8 sin theta minus 3 cos theta divided by 8 sin theta plus 2 cos theta? Alright, so let's see what is sin theta is equal to. Some people have, so perpendicular by hypotenuse, 4x by square root of 41x, 4 by square root of 41, and cos theta would be base by hypotenuse. So 5x divided by hypotenuse is square root of 41x, that is x gets cancelled, 5 by square root of 41. Now let's straight away substitute it in this and see what happens. So 8 into 4 divided by square root of 41 minus 3 into 5 divided by square root of 41 divided by 8 into 4 divided by square root of 41 plus 2 into 5 divided by square root of 41. So I urge you to pause the video and try to do this calculation. You would have got 17 by square root of 41 by 42 by square root of 41, and that would be 17 by 42, because the square root of 41 get cancelled. Or let's write one more step here. So this would be 17 by square root of 41 into square root of 41 divided by 42, that is 17 by 42. All right, so that's how we do this. So this is approach 1. Now there is a second approach which could be a little bit more interesting, and let's try that approach as well. So in this approach, what we do is we look at this pattern, the sine and cos, and if you have a pattern like this, you can divide the numerator and denominator by cos and eliminate cos and make sine by cos is tan. So let me show you what I mean by that. So approach 2 would be 8 sine theta minus 3 cos theta divided by 8 sin theta plus 2 cos theta. So we can divide both numerator and denominator by cos theta, and that ratio would not change, and the top would become 8 times sin theta by cos theta minus 3 divided by 8 times sin theta by cos theta plus 2, and that would be 8 tan theta minus 3 by 8 tan theta plus 2, and we know that tan theta is 4 by 5, so we can straight away substitute now 4 by 5. So 8 into 4 by 5 minus 3 divided by 8 into 4 by 5 plus 2. And if you do this calculation, you will find that you get the same answer, which is 17 by 42. So you can do this and check for yourself if you're getting the same answer in both these approaches, right? All right, so let's do the final problem. Let's look at this problem and pause the video, take some time out, read the problem, and try to represent this problem in the form of a picture and try to think through this. So here, without trying to solve the problem, we have just represented this problem here in the form of this diagram. So here the questioner is asking what is tan of theta 1? Tan of theta 1. So instead of saying DBC, we have marked the angle as theta 1, and they are asking what is tan of theta 2. So straight away we know that tan theta 1 is, if you look at the triangle BDC, if it's not clear, we can actually redraw this as follows, or rather it's easier to kind of imagine you look like this. So for this triangle, this is a perpendicular and this is a base. So tan theta is still painted black, so tan theta 1 is equal to perpendicular by base, and that perpendicular would be DC divided by dB. And similarly for tan theta 2 would be, the perpendicular would be AD by base would be dB. Now when you look at this, it looks very difficult and impossible to find out because we don't know any of these values. But the trick is in trying to decode the angle. So let's mark this as, instead of theta 1, let's say this is theta, and since this side is perpendicular, then this will be 90 minus theta. And now if this in triangle ADB, if this is 90 minus theta, this has to be theta, right? So this has to be theta because the sum of the three angles should be 180. That will make that theta. And then if this is 90, this is 90 minus theta in the triangle DBC, right? So the moment you understand these various angles, then the problem becomes a little bit more simpler, because here instead of theta 1, I can say this is tan theta, and here theta 2, this is tan of 90 minus theta. All right, so now that we have this, now we see obviously the pattern in the big triangle, in triangle ABC, tan C, or tan 90 minus theta, right, is perpendicular by base, that is 4 by 3, and tan of theta would be, you're basically viewing from here. So that's nothing but tan A equal to perpendicular by base for tan A would be, perpendicular would be 3 and base would be 4, right? So now that would imply that tan of theta 1 or tan of angle DBC is equal to this angle. Now we know that tan theta is 3 by 4, so we can say this is 3 by 4, and tan of angle DBA is nothing but tan of 90 minus theta, which is tan of 90 minus theta, which already we have found it as 4 by 3. So I know this problem may not be looking easy at the first attempt, but as you reflect the angles of the triangle and try to look at it from that point of view, things would look much more simpler. Now the second part of the question is asking what is sine of angle D by A. So what is sine of angle DBA, right? So sine of that angle would be sine of 90 minus theta, right? And sine of 90 minus theta is also equal to sine C, and that is equal to perpendicular by hypotenuse. So if this is 3, this is 4, this whole thing should be 5. So this whole thing should be 5, right? So sine C would be perpendicular by hypotenuse, which is equal to 4 by 5. So that would be our answer. So I hope you are comfortable and you are comfortable with the trigonometric problems. Now you will gain more and more expertise as you practice, and things will look quite simple once you practice a lot of problems. So I urge you to do a lot of problems and wish you a lot of good luck. See you in the next one. Bye.